Hey guys, today we're going to be talking about lesson 3 from unit 4. So let's get into it. It's called Understanding Experimental Probability, and the goal is that you'll be able to determine the experimental probability of an event. So let's get to the page. We're going to start on page 9, warm-up. So that should say 4. I'm so sorry. Lesson 4.3, warm-up. It says, Keith is awarded a penalty shot. He will either score a goal or not score a goal. Are both outcomes equally likely and explained? Now, I am not a hockey expert by any means. I mean, I guess it's called to be for soccer, but I'm not a sports expert. But what I do know is that you either going to make it or you're not. So theoretically, the theoretical probability, I'm just going to put prob, is 50%, right? You either make it or you don't. There's only 2 options, or you can say 1 out of 2 options. You're either going to make it or you're not. However, in actuality, in real life, it really depends on how good of a goalie you have. And that makes sense, right? If you have a pretty bad goalie, like if I was goalie, they'll probably make more than 50% of their shots. Versus if it's a really good goalie, like someone who plays the sport professionally, then they'll probably make less than 50% of the shots. So it really would depend, and that's what we're going to talk about today. We've been talking about theoretical, what should happen, versus what actually happens, our experimental probability. So let's talk about relative frequency. As our definition, the definition of relative frequency is how often something happens divided by all the outcomes, or you can call that the total number of trials. So this is the real life, what actually happens. You run an experiment, you will have all your favorable, what you wanted to happen over the number of times you ran the experiment. So let's do some practicing with that. We have example 1 here. It says, what is the theoretical probability of landing on a 2 or higher? So we know the number of outcomes are 1, 2, 3, 4, 5. And the number of favorable outcomes, or what we want to happen, says 2 or higher, which means we include 2, 3, 4, and 5. So that would be 4. So we have 4 out of 5, which is 4 divided by 5 gives you 0.8. which gives you 80%. So we have a theoretical probability of 80%. You have an 80% chance of landing on a 2 or higher. So let's figure out what the experimental probability. To do that, we have to look at this table over here. It says the table shows one student's results of spinning the pointer 30 times. And then don't worry about the complete part A and B. So this says for 1, the outcome 1, or landing on 1, they had 9 times. 2, they had 5. 3, they had 5. 4, they had 7. And 5, they had 4. So we want to know the experimental of 2 or higher. So we're going to say our probability of 2 or higher is equal to, and we're going to go look at the frequencies. We have, on our 2 or higher, we have 5 plus 5 plus 7 plus 4, all over the total number of outcomes. Well, they did it 30 times, so it's going to go over 30. So now we have 5 plus 5 plus 7 plus 4 gives us 21 over 30. So now we need to figure out, well, what is 21 over 30? I mean, we could leave it like this, but no, we have to simplify it. But let's simplify it first. They both can be divided by 3, which means you have 7 over 10. Well, 7 over 10 as a decimal is 0.7, or as a percent, we have 70%. So this is an instance where, while theoretically he should have gotten 80% for 2 or higher, we actually only got 70%. And it's kind of close, but not exactly what we needed. So this is when experimental doesn't always match up with theoretical. Now, if we were to do this experiment hundreds of thousands of times, the more times we do it, the closer we will get to our theoretical. The less times we do it, the more inaccurate our experimental will be. So the more trials you have, the more accurate your experimental probability will be to your theoretical. So let's go do some more examples. Example 2. All right, so we have this table over here, and it's that spinner we had before where there was 2 winners and 16 outcomes. Well, the students who used it said between 10 a.m. and noon they had a total of 213 players and 22 winners, and between noon and 2 p.m. we had 262 people for 36 winners. So, and then in total they have 475 and 58 winners. So now let's remind ourselves what that theoretical probability of winning was. There are 16 outcomes if you count them, and there's only 2 winners, so you only have 2 favorable outcomes. Well, that would give us a 0.125 as our number, which is 12.5%. So our theoretical probability of winning is 12.5%. And we did this on last unit when we did last lesson when we did theoretical probability. We had this exact will. So now what is experimental probability? Well, we're going to take our total number of winners and divide it by our total number of people or players. So this time we're going to say 58, and I almost forgot our label. We're going to say P winners equals, and we'll say 58 over 475. And so then, because again, that is our winners over our total number of players, which gets us 58 divided by 475 gives us a number 0.1221 because it goes on and on and on. It is not a terminating decimal, but that's okay because we're going to round it to the nearest hundredth once we turn it into a percent. So we're going to multiply that by 100, and that's going to give us 12 point, and we're going to round. Actually, let's round to the nearest tenth. There's going to be a 2. There's a 1 after it, so 12.2. So about, because it's not exact, so about 12.2% is what you get. And that's pretty close to what we had over here. We had 12.5. 12.2 is pretty close to that, but it's not exact. So again, our experiment wasn't close, but we used bigger numbers, and the bigger numbers got us closer to what the theoretical is. Now I want to talk about relative frequency. And relative frequency and experimental probability can be used actually interchangeably, but it's also can be used for segments of the entire total. The experimental probability usually refers to the entire total, not always, but relative frequency is just saying, well, how frequently does something happen? So let's find the relative frequency of, and I want you guys to cross out this question mark because I meant to put of each time period. So we're going to check what is the relative frequency of the morning and what is the relative frequency in the afternoon. So the morning was, and we'll write morning so we know which one we're talking about. Oh, there's no I. Sorry, guys. Morning, we had 22 out of 213. Well, 22 out of 213, we do divide 22 divided by 13, and we get 213, sorry. A really long number that ends up rounding to be about 0.103, and we get which equals about 10.3%. In the afternoon, you have 36 over 262. Now you remember you have to make sure you use the ones. You can't use 475 because that's not the total. That is the total for the entire thing, not just that portion. So you have to use the portion it goes to. 36 divided by 262, and that gives you another long number that we're going to just take the first 3 after the decimal, 0.137, or about 13.7%. Now, if you want to know if your relative frequency is right for the beginning or your experimental, you would know that because these two make up this one, it should fall in about the middle. And it does. It falls between 10.3 and 13.7, about the middle of that. This number should always fall in the middle of these two because these two make it up. It's like the average of it. All right, now that we figured out some relative frequency, let's go ahead and try another one. We're going to do a theoretical versus the experimental probability. So now it says, what is the theoretical probability of landing on heads for Amir and Marvin? Well, first we need to figure out, well, what are the total number of outcomes? Well, 26 plus 24 gives us 50, and 30 plus 20 gives us 50. So the total number of outcomes equals 50. So now, of 50, how many heads would we expect Amir or Marvin to have? Well, it should be the same because the theoretical probability of, and I'm just going to put TP, of getting a heads would be 1 out of 2. You have a 1 out of 2 chance or a 50% chance. Well, 1 out of 2, half of 50 is 25 heads for both. Both of them should expect to get 25 heads, but as we see, that didn't happen. So let's figure out what was the experimental probability. So the probability of getting heads for Amir, and then we'll do Marvin down here. Probability of getting heads equals, and of the 50 times they flipped, he got heads 26 times, which 26 divided by 50 gives you 0.52, or 52%, which is not exactly 50% like we thought. And what is the probability of Marvin getting a heads coin? Would be 30 out of 50, which gives us 0.6, or 60%. So these are kind of off, but that's what we usually see with experimental. Experimental is what actually happened. Theoretically, this is what they should have gotten. All right, last example. Using this grid, how many winners can you expect if with 300 participants? So we know we got our total down here. Oops, sorry guys. 71 winners out of 416. There's 2 methods you can do this with. We're going to use the first method, 1, and I want you to put in, this is the most accurate, is using proportional reasoning. We can say, well, there were 71 winners out of 416 winners, and that should equal, well, how many winners should we expect out of 300? And like we've been doing, we cross multiply, and we have 416 times x, or just 416x, equals 71 times 300, gives us 21,300. Well, we have to divide this 21,300 amongst the 416 x's, so divide by 416 on both sides. And we now have x equaling 51.2. And make sure, and that's when I rounded to the nearest hundredth, or one place after the decimal. Now that's method 1. Method 2, oh, sorry guys, let me make that up small. We would say Well, they already figured out the percent for us, didn't they? Look up here. They already said it was about, they rounded, 17.1%. Well, what you could say is you can turn 17.1 back into a decimal. So you say 17.1 and you divide that by 100, which gives us 0.171. And then you take your 300 and you multiply it by 0.171 because we want to figure out what is 17.1%, and that should give you 51.3. So as you see, it's not actually as accurate, and the reason is because it's been rounded. So since this has been rounded, it's not going to give you the exact same number. But it's pretty close. It's only off by a tenth. I think that's pretty close, and it's an acceptable answer for me. So if you rather use the proportional method, please go by all means do it. If you think, well, no, I like just multiplying it by the percent as a decimal, that works as well. Either way, you have it with 300 people, and make sure you write your answer on the bottom. Either method, you say with 300 people. You should expect 51 winners. And there you go. That's it, guys. If you have any questions, let me know. Sorry for such a long video this time.